Greetings to you all. This is unit number 6 about polymers that is continuing. Last time we explained the concepts of polymer, monomer, and the concept of polymerization, and we focused on addition polymerization. Today we are going to look at condensation polymerization. Condensation polymerization is a chemical process in which many bifunctional monomers combine together to form the polymer with elimination of a small molecule of water, or ammonia, alcohol, or hydrogen chloride. Let's take the example here. We have two monomers. One is a diamine, another one is a dicarboxylic acid. As you can see, the monomers have different functional groups. They combine together by losing hydrogen for amine functional group and then OH for a dicarboxylic functional group. They form a molecule of water as a byproduct, and then there is a polymer which is formed. So what is very important to be noted here is that for condensation polymer, we have a linkage group. A linkage group is a functional group that joins the monomer molecules together. Another thing that is very important is that the polymer is not the only product that is formed, like we have seen for addition polymerization. The third thing that is very important is that the monomer molecules have different functional groups, while for addition polymerization we have seen that the monomer contains one functional group or the same functional group, which is anisaturation, a double bond between carbon atoms or a triple bond between carbon atoms. The fourth is that condensation polymerization requires lower temperature if you compare to addition polymerization. This is because the functional groups that are involved in condensation polymerization are reactive among themselves. This does not require a lot of heat, while for addition polymerization, a lot of heat is required to break the double bond so that the polymerization can take place, and we need also heat to form radicals that initiate the polymerization. Let us now see what are the common condensation polymers. Some of the common condensation polymers are polyesters. In polyesters we have Dacron or Terylene, and this one is a polymer formed by a diol with a dicarboxylic acid. When these two combine together, there is elimination of a molecule of water, and there is a formation of a polymer that has the linkage group that is an ester functional group, where the name polyester. Terylene consists of strong and durable fibers used in textile industries to make clothes. Fibers are like threads, and they are used in textile industries to make clothes. The images beside here show you some of the uses of Terylene or Dacron. You can see here we have this handbag, we have the rope, we have the cloth, we have the bed cover, the pillows. So there are many uses in the textile industries. Other common example of polyesters is Glyptal. Glyptal results from the combination of ethane 1,2-diol and benzene 1,2-dicarboxylic acid. They combine together by the dicarboxylic acid losing OH, and the alcohol functional group loses hydrogen. They combine together to eliminate a molecule of water, as it is a condensation polymer, and then there is formation of a polymer that has the linkage group is an ester functional group. As we have said before, that they are polyesters. Glyptal is mainly used in the paint industries and lacquers. Lacquers are liquid solutions that can be used to paint metallic or wooden objects. The examples here are that they are painting these metallic objects to prevent them from rusting or to prevent corrosion. You can see these images are showing it clearly. This is Glyptal that is used to paint the metallic objects. Polyesters have one weakness, that they can easily be hydrolyzed by strong alkaline or acidic solutions, which helps us to understand the reason why we should keep the polyester materials away from strong alkaline solution or strong acidic solutions. As you can see, the hydrolysis can damage or deteriorate the material into these components that are given on these reactions that are on this slide. Other types of condensation polymers are polyamides. As the name indicates it, they have amide functional group as the linkage group. Now all these examples that we have here, you can see that the linkage group is amide functional group. So the common examples of polyamides are synthetic nylons. Nylon is a polyamide that results from the combination of dicarboxylic acid and diamine. So the numbers that we have here indicate the number of carbon atoms that makes the monomers. You can see that, for example, nylon 6,6, the number 6 means that the dicarboxylic acid has 6 carbons. These are 4 carbons plus these other 2 we have here. So there are 6 carbons. When you check on the diamine, we also have 6 carbons. So the polymer that results from this combination is nylon 6,6. We have nylon 2, nylon 6. Of course, it means that one monomer has 2 carbon atoms and another one has 6 carbon atoms. These are 5 and 1 here. They are 6. We have nylon 6, which is a homopolymer, and it only has 6 carbons. These are 5, and this is another one to make 6 carbon. It results from an amino acid, as you can see, carboxylic acid functional group and amine functional group. So nylon are mainly used in the textile industries to make different fabrics, where we can have clothes. You can see this is a shirt. We have ropes. Here the images are showing it. These are ropes. We have toothbrushes. Can also be used to make hair extension for ladies, you know it very well. And then to make different threads that are used in sewing. So these are nylons. Other common polyamides are aromatic polyamides, where we have Kevlar polymer. In the Kevlar polymer, we have the combination of benzene 1,4-dicarboxylic acid and benzene 1,4-diamine, and when they combine together, there is a molecule of water that is eliminated, what makes it a condensation polymer. And then it is a polyamide because the linkage group here is amide functional group. We also have Nomex, and Nomex here we have the combination of 1,4,1,3-diaminobenzene and 1,3-benzene diacyl chloride. When they combine together again, we can see that one loses chlorine, another one loses hydrogen, and then we have elimination of a molecule of hydrogen chloride. And then it is a polyamide because the linkage group is amide functional group. The main difference between Kevlar polymer and Nomex polymer is that the arrangement of the functional group in Kevlar are in para position, that is 1, 4. While for Nomex, the arrangement is in meta position, that is 1, 3. 1, 3. So this also causes the difference in their properties, whereby Kevlar polymer has higher melting and boiling point than Nomex polymer, and Kevlar polymer is stronger than Nomex polymer. This is because Kevlar polymer molecules can easily be packed together, and this results into stronger intermolecular forces because this facilitates many points of contact between molecules. While for Nomex, the benzene ring that comes out of the chain prevents the arrangement, proper arrangement like we have it in Kevlar polymer. The main uses of Kevlar polymer are in the textile industries also, but we have it used in making helmet for military, for soldiers, helmets. We have Kevlar polymer that can also be used to make bulletproof vests. We have Kevlar polymer that is used in the textile industries to make jeans and other different fabrics. For Nomex, it is mainly used to make firefighter clothes, firefighters clothes. So these are the clothes for firefighters, the gloves, the trousers, and the jacket for firefighters, or to make other fabrics in the textile industries. So these are polyamides. Polyamides molecule interact by strong hydrogen bonds, as you can see it here. For nylons, for Kevlar, for Nomex, they all interact by hydrogen bonds because they contain hydrogen bonded to nitrogen, and there is oxygen present in the functional group, in the linkage functional group. So this makes them interact by hydrogen bonds. That makes them strong and resistant to tension forces. As we have seen that polyester materials, we should keep them away from strong alkaline and acidic solutions. Polyamides also, we should avoid them being in contact with strong acids and strong alkaline solutions. But most especially for polyamides, we should keep them away from strong acids because they are the ones that affect them very much. When this happens, of course, they get hydrolyzed into carboxylic acid functional group, and ammonium ion. This happens by the fact that water molecule that is in the solution, of course, leads to formation of carboxylic acid functional group here. And then the hydrogen ion from the acid, this one, combines with this to form ammonium ion that we have in the product. So another common condensation polymer is bakelite, and it has also so many uses. Bakelite is a result of the polymerization of phenol with formaldehyde that first forms Novarac, which is a linear polymer, and we also have it combining with formaldehyde to result into bakelite, and bakelite develops cross links between the main chain polymer molecules. Which of these ones? These cross links that develop between the polymer molecules give them strength. That's the reason why you can see that bakelite is used to make, this is a watch, for example, but you have these bracelets. We also have gun magazine. We have a telephone cover. We have the switch and the socket for electricity appliances. We have beard balls here, those people who play beard. We also have buttons that we have in our clothes. On this activity, you are going to use relevant examples to compare addition with condensation polymerization. Number 2, you are going to determine the structure of the monomers and the repeat unity, and then draw a ring around the linkage group for a given polymer. Here it's nylon 611. Then lastly, you are going to explain the reason why the materials made of polyesters and polyamides should be kept away from solutions of strong alkaline and acidic solutions respectively. So it means that why should we be careful when we are having materials made of polyamides or polyesters in case that they are to be in contact with the strong acids or strong alkaline solutions. Thank you very much. I think you have enjoyed the session. We shall meet next time for the continuation of this unity because we have not yet ended it.